In this problem, we want to find all positive integers n such that n squared plus 1 is divisible by n plus 1. So, when we first look at this problem, we might think about us first trying some few small values. So let's do that. Let's test some small positive integers for n. Well, if you have n equals to 1, then n plus 1 equals to 2. N squared plus 1 equals to 1 squared plus 1 equals to 2. So we have 2 equals to 2. So n equals to 1 is a solution. If we test n equals to 2, then n plus 1 equals to 3. N squared plus 1 equals to 2 squared plus 1 equals to 5. And we all know that 3 is not equal to 5. So this doesn't work. Then n equals to 3, we'll have n plus 1 equals to 4, n squared plus 1 equals to 3 squared plus 1 equals to 10. And 4 is clearly not equal to 10. So this doesn't work either. So if you keep on trying, for example, n equals to 4, n equals to 5, well, you'll see that they all don't work. So it seems like n equals to 1 might be the only solution. But how do we prove that? And what if there's a huge solution we're missing? Well, the phrase is divisible by is a huge hint to its properties of divisibility, or in other words, modular arithmetic. So if we are given that n plus 1 is going to be a factor of n squared plus 1. And here's the trick. Let's first transfer this into congruence modulo. N squared plus 1 would be congruent to 0 mod n plus 1. Then, here's the trick. We want to get rid of that n in the n squared plus 1 term. We know that n is congruent to -1 mod n plus 1. So, let's substitute this into the expression n squared plus 1. N squared plus 1 is congruent to -1 squared plus 1 mod n plus 1. So n squared plus 1 will be congruent to 1 plus 1, or congruent to 2 mod n plus 1. So the original condition n squared plus 1 is congruent to 0 mod n plus 1 now becomes 2 is congruent to 0 mod n plus 1. So what does this mean? It means that 2 is divisible by n plus 1. In other words, n plus 1 must be a divisor of 2. So we have n plus 1 must be a divisor of 2. What are the divisors of 2? Well, the divisors of 2 are plus minus 1 and plus minus 2. So, n plus 1 must be one of these values. N plus 1 equals to 1, n equals to 0. N plus 1 equals to -1, n equals to -2. N plus 1 equals to 2, n equals to 1. N plus 1 equals to -2, n equals to negative 3. The problem specifically asks for positive integers n. Looking at our list of possibilities for n equals to 0, n equals to negative 2, and n equals to negative 3, they're all not positive integers. The only correct answer, or the only positive integer solution, is n equals to 1. So our conclusion is that it turns out that our initial trial and error was actually complete. The only positive integer n for which n squared plus 1 is divisible by n plus 1 is n equals to 1. So that is how you solve this problem.